I'm trying to work off a food coma. Food comas. Oh boy, are great like that. So I have my water bottle here. And as you can see, in the upper right part of your screen, you can actually see my notebook in my hand. I remember I spoke about this last time. So I do a lot of stuff by writing. You know, when I was in college, in order to kind of really learn how a linked list work, I wrote it down, and so I'm doing that with this. And so with this, and as well with the Haskell thing, which I think I'm going to be streaming instead of just recording on YouTube, so I'm taking off my socks, it's now really hot. Now that stuff, you know, I want to write in my notebook, but I didn't because there's no camera on the notebook. And so you guys who are just watching my screen wouldn't really see anything. So to make it so I can use my notebook, I have put this here. Now, it's far enough away where you may not be able to see what I'm writing. Like if I make something pretty big like this. Hi, I think you can read that. Can't really see. I don't know, maybe. So, I'm watching my, yeah, you can read it. So, but this will just be more for me, but I just want to have the notebook here, just so you guys can really see what's happening. So, where did we leave off? Yesterday. Last time, not yesterday, oh, by the way, I'm sorry I'm not streaming for that programming guy on a regular schedule. I've been meaning to, and my wife is in the hospital now. She's been for a while. So it makes it really hard to kind of get home between 8 and 9, because I just want to stay there. But yeah, so who's with me today? So, yeah, so that's what's going on. I'm still going to try to stream weekly. I'm additionally going to try to change my That Programming Guy schedule to Wednesday nights to see how that goes, because Mondays weren't working, and I would like to stream more. I like this project. I think it's great. So yeah, so where we left off yesterday, not yesterday, the date, last time I streamed, was we had written our first part of assembly how I want to make it, because I have my own assembler that I can do. And doing that. So, yeah. So, and also reading about assembler directives, because I saw a lot of stuff that wasn't a 68K directive. So I was like, okay, this is weird. So there's assembler directives, which tells the assembler to do something. So you have like constants, or like where the program starts, or and then you have the actual instructions. So that's kind of what I was getting yesterday. So today we have this. So here's that says add. So basically we're taking a byte, which is 1, and we're going to say place it in, probably should be D0 instead. So something like that. There you go, assembly. It's saying basically take 1 and add it to whatever is in here, and that's it. So now we have the the emulator we need to worry about. So the emulator, right, because we're going to want to run this, has really cool stuff in it. Basically, for integer, unit, user, program model, floating point, or supervisor program model. So I don't know how exactly we would switch the programming models. System programmers use the supervisor program model to implement sensitive operating system functions, I/O control, memory management unit, subsystems. The following paragraph briefly describes the registers. I'm not going to have to worry about this right now. It's just basically what would we use each mode for. Like, I kind of get it. We'd use the integer unit user programming model if we're not going to deal with floating points. And I get that, and I think that's just what we're going to start with. We're just going to say we're using integers, and that's it. I don't know exactly how you would specify what model to use. Two register groups, user and supervisor. User programs executing the user mode only use the registers in the user group. System software executing in the supervisor mode can access all registers and uses the control register in the supervisor to perform supervisor functions. The following paragraph provides a brief description of the registers in the user and supervisor models, as well as the data organized in the registers. So we're just going to right now start with the integer unit user programming model. And another question as well that's coming up that I'm thinking was like, how exactly would we deal with testing? You know, how do we make sure the add works out it's supposed to? How do we make sure everything else works it's supposed to? So 16 general purpose 32-bit registers. So we are going to have a register. No, we're not. We're not going to. No. Well, I'm not going to abstract anything out yet because I'm really lazy and I don't want to. So we have D0 through D7. So we have a static. Oh, we're going to make static right now. Whatever. Static. Data. Static. Int 32 data register. Equals new int 2. There's 8 of those. Right, we are in C# world, not C++ world. There we go. Data address. Address register. We are going to do, since I've built, whatever, I'll just do one or the other. 16 address registers, a program counter, and that. So address registers, and then a 32-bit program counter. Static, it's 32 program counter. And do we have a 8-bit condition code register? 8. Oh, I don't have an int 8. Static byte. There we go. Cool. So we start everything out like that. I mean, this is going to be uber simple, right? So basically the idea is we're just going to start simple and work our way up to more complicated. That's the idea. It'll be fun. So I don't even know why I'm doing this. We should actually not start with this first. Here's what we're going to do. I'm going to fucking go to add. ADD. Oh, that McDonald's is getting to me. There we go. Add binary. So we have add ADD. We can also do this. Add binary. Right? So we have destination, source, destination. So we have two things. So what I did was I did this. I've add effective address. And then we have the destination, or the data register to put it in. And we can make it a byte, we can make it a word, or we can make it a long word. What does the wife want? Not the wife. Tierney. Who is the wife, except she's not texting me. She's texting me and her dad. There we go. All right. So, condition codes. X, N, Z, V, and C. Source, operand, addressing modes. We can use the data register and address register and all of this stuff, or immediate. Destination operand can only be one of these. Oh, I don't have anything, so I'm gonna have to look at the other one. Okay, let me look at the other one. And also the 30 CCR program counter. The piece consistent of 5 bits. Oh, just 5 bits. Well, if it's 5 bits, then let's just do this. C# bit flags. Cool. Flags public enum. Flag. Yeah, that's fine. I can do that. The status register's lower byte is the only portion of the status register available in the user meaning integer instructions like the CCR, indicating the instruction's result. Program and system control instructions also use certain combinations of these bits. The condition codes meet 2 criteria. Consistency across instructions uses in instances. Consistency across instructions means that all instructions that are special cases and more general affect the condition codes in the same way. The first 4 bits represent a condition of the result generated by the operation. The 5th bit, or the extended bit, is the operand for a multi-precision computation. The carry bit and the X bit are separate in the 68,000th family. To simplify program techniques that use them, refer to the 18 instructions. Oh, right. So X is extend. So yeah, I use this a lot. Extend. Negative. Z equals 0. V equals overflow. C equals carry. Set the value of this C bit for the arithmetic operation otherwise not affected, or set to a specified result. Set if the most significant bit of the result is set, otherwise clear. Z is 0. Set if the result equals 0, otherwise clear. V. Set if the arithmetic overflow occurs, implying that the result can be represented in the operand size, otherwise clear. Set if the carry if a carry out of the most significant bit of the operand occurs for an addition. Okay. This will be fun, guys. I'm really excited. And make sure to keep your hydration up, everyone. You really don't want to lose your hydration. Because once you're dehydrated, you just feel miserable and it's not fun. However, it also goes on the other way, too. You don't want to be hydrated either. Sorry, overhydrated. So the first 4 bits represent a condition result. Okay, so you go like this. So this is bit 0, bit 1, bit 2, bit 3, bit 4. Set to the value of the C bit for arithmetic operations, otherwise not affected. Okay, so basically set to the value of C bit for arithmetic operations, so I'm guessing the X bit is set after the C bit is set. Okay. The status register's lower byte is the only portion of the status register available to user mode. I see, so if we have the CCR in the supervised thingamabobber, floating point instruction address register, supervisor programming model. Whoa. What is all this? Oh, wow, there's a lot more. That's 16 bits. Oh, damn. Well, I'm really glad I'm starting with just the freaking integers. Jesus Christ. This is insane. Why is there so much? Yes, I want to get to the start. 1632. All right, that's cool. A0 through A6 is the address registers. A7 is the stack pointer. I see. So then we also have the stack pointer, which is going to be A7. That's cool. Your register A7 is used as the hardware stack pointer doing stacking for subroutine calls and exception handling. In the user program model, A7 refers to the user stack pointer. Okay. And then another thing we're going to have to worry about is really to make sure we don't use more memory than we're allowed to. Okay, so that's cool. So let's get to add, right? By the way, guys, did you know that what was it? You can play Phantasy Star Online Blue Burst, and there are people who just like keep a public server up that other people can play on, and it's just so cool, and I love it. I really like Phantasy Star Online. Like I'm probably after this I'm just going to play that on Active Fireball. I just absolutely love Phantasy Star Online. I grew up with that when I was younger. So adds the source operand to the destination operand using binary addition and stores the result in the destination location. The size of the operation may be specified as a byte, word, or long. The mode of the instruction indicates what operand is the source and what destination as well as the operand size. So, X set the same as carry bit. C is the result is negative, otherwise clear it. Z is the result of 0, otherwise clear it. V if overflow is generated. C if the carry is generated. So technically, no, that wouldn't be a good idea. How would you test for overflow? In C#, the only way I could think of it would be to catch. But that's insanely slow, and that's not good. Especially for an assembler, that's not good. You know, if Chiroptical was here, I'd totally show him my dog. Because Chiroptical is weird. And I have like 2 viewers, but nobody in chat. That's weird. Alright, so we have 3 ones. We have EA, DN to DN. So if we have the effective address, which is the source, add it to the destination and put it into the destination. Or we have the data register, and then basically the source is the data register. The destination is the effective address and put in the effective address. So I'm going to worry about with this right now. So we have add, right? So we have a byte. So the effective address is mode and register. So if we have add, so if we turn this around, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I did this a lot in college on how to make arrays instead of just making all the boxes separately. Do that, it makes life a bit easier. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You know, this would actually be much better if I had graph paper. This would work really good with the graph paper. So basically, 0, 1, 2 is register. 3, 4, and 5 is equal to mode. 6, 7, 8 op mode. 9, 10, 11 is equal to register. And then 12 is equal to 1. 13 is equal to 0. 14 is equal to 1. 15 is equal to 1. Cool. So the question is, specify register field specifies any of the 8 data registers. This is the effective address. Register field, data register. Op mode field, the byte, word, or long. Effective address. If the location specified is the source operand, all addressing modes can be used as listed as followed. If the location is the then we can use that. Note, the DN mode is used when the destination data register. So here's my question, right? So we have, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, 0. If we want to write, for example, a word, would we write down in here 0, 0, 1, and then have the other bits? Or do we do 1, 0, 0? Sorry. 1, 0, 0. And do it that way. I'm guessing since it's right to left, I have actually no fucking idea how this would work. Because I would have no idea. Because it could be that this is read, this is made for humans to read, but it has to be reversed. Do you tell me? The mode of the instruction indicates which operand is the source and which is the destination, as well as the operand size. The section contains detailed information about the integer instructions of the M68000 family. A detailed discussion of each instruction description is arranged in alphabetical order by instruction mnemonic. Each instruction description identifies the difference among the 68000 family for that instruction. Noted under the title of the instruction are all specific processes that apply. Identify within the paragraph a specific processors that use different instructions. Yes. Appendix A, process instruction summary, provides lists of all processors and the instructions that apply for quick reference. So again, which one is it? I mean, again, I'm making the emulator so I could do what I want, but if I write the assembler and I write output binary and the emulator doesn't understand, then I'm going to have to switch it around. But it's the same thing with the mode and, with the register and the op mode and this register. In what order do I put them? Because it could be 1, 1, it could be 1, 1, 0, 1. The 3 bytes are for the register, the 3 bits for the register, the 3 bits for the op mode. So whatever register and then the op mode. I think it's just basically replace. I guess I'm gonna start with that, with just the replace. So if we're going backwards, it'd be reversed. So I'm gonna start that. So the register, and you should be hearing my clock, taking my wife's mom's clock. It's a very nice sound. That won't be, I don't think it'll be in future ones, because I'm actually just waiting for the striker to lose its tension. So right now we have EA DN to DN. And so because of that, so if we continue with this, right? If we just say this, no, this. So if we go, if this is our example, add byte 1 D0. Let's put a hash in front of that. So we would have from 0, 1, 2, it would be the register of the effective address, which is immediate. So the register would be, I'm guessing 0, 0, 1. The mode will be 1, 1, 1. 1, 1, 1. The op mode, if I'm using a byte and I'm like this, would be 0, 0, 0. And then the register this is going to go into is D0. Which is 0, 0, 0. And then we have what's left over is 1, 0, 1, 1. So 3 bits for the register, 3 bits for the mode, 3 bits for the op mode, 3 bits for the destination, for the register, and then 4. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There you go. We have it. So basically, this is what's going to be outputted in the source file. Is 001 111 000 000 1011. That is what is going to go into it. Cool. So great. So we did that. So now it's the logic of figuring that out. So what are the decisions that we have to make? Yeah, no, this is so much more easier now that I can write. Oh my god. Writing stuff is making this so much more easier. It's pretty great. Hey, look, I have actually people in chat. And I wonder if all of them are bots. Who knows? Who cares? So so the decisions we have to make, right? Decisions. This is for add. 1 is if it's EA DN or DN EA. So that's the first decision we have to make. The second decision we have to make is if it's a byte, if it's a word, if it's a long. That's it. That's the only decisions we have to make. So, however, from there, so the first question is, on the add, how do we tell if it's the effective address and the data register, or if the data register is first and then EA? So here's how we know, right? So DN can actually be, done in multiple ways. If the effective address field, I see. So we would have D0, D1, D2, D3, D4, D5, D6. 1, 2, and D7. Right? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So that's how do we know. We basically say, what's the first one? Is it starts with a D? Then we're in here. If it does not start with D, it's here. I get right? Cool. Wonderful. So if the location is specified, then we have to have this table right here, like this giant thing, and we have to know what the allowed modes are and what the allowed modes are not. Which is quite interesting. I don't know what XXXW and XXXL is. But this is the literal. So I wonder if this is the same. Like through everything. Yeah, I think they're the same. I think it is. But I'm gonna leave it. So basically we have to have this table in here. Cool. So I also, another thing that I'd want to do is instead of doing add, I'd also just like to go add binary. But if I have everything space delimited, this can't be a space. It would have to be an underscore, or it would better just be add binary. And then yeah, that would work just that. And just keep everything space delimited. And then have comments be like semicolons or something. I could do that. So now I have to be able to take this command. And so I need a parse command, I guess. So if we go to the assembler, right? Here's all the cool stuff. You know what? You know what? This is a lot of shit. This is a lot of shit. I don't know if I want to read all of this right now. No. All this is going to go away. I don't want it. Like, I will have it eventually. Like, I will have it, and I think that's a great idea. But at the moment, I don't want to deal with it. So let's just, whatever, we'll keep it. Just, now, I guess, readers where it's supposed to be. So I'm just going to leave it here. So we're going to have an add. So we need to take it, and we need to know first. So I guess the first decision is, what instruction is it? What instruction is it? So we have multiple instructions that we're going to have to start doing. So, I mean, we could be really fancy and do this with reflections and be like, oh, we have an add. Cool. Make an object that has the word add, and then make that, and invoke this function. But I'm not going to do that. It's a cool idea, though. Why am I not going to do it? Because reflections are slow. Alright, so first thing is we need to do add. So it means we need to get, we need the instruction mnemonic. So here's what we're going to do. We're going to string so this would be a split on a space. Is that how you spell mnemonic? I really don't think that's how you spell mnemonic. M and ooh, can I do this? Ooh, computer, are you smart enough to do this for me? Hell yeah! There we go. Cool. So, I mean, we could have a giant, just a giant switch case statement. But really what we should be doing, or what we'll have be doing, is basically going, probably some kind of factory that's like, okay, make the add object. Or just have a static class almost, and just be like, process this as an add instruction. Or I could use, you go object oriented like, and go, okay, cool. Make me an add object and then process it. Here's the instructions you need to process. And then give me back a string. And that's a cool idea. That's a cool idea and everything. However, Um, that's a cool idea and everything. However, the only problem with that is I'd constantly be making things and unmaking them, which wouldn't be cool. Why did my phone make noise? Redfin. Nope, fuck you, Redfin. And then we have to output the string, so we also need to stream a writer. I don't know why I did that way. There we go. Sure, we'll just drop it as a TXT right now. There we go. Cool. I think that's too much water. I think I'm going to food coma. I mean, overhydration. I don't know. I can't really tell. Can you? Alright, so now we got the instruction. So we know what the instruction is, which is add. I just know that right now, which is fine. So we now need to process the instruction add. So there's gonna be a lot of stuff here. So we're just gonna write a method called static string process add. Arguments. Hell yeah. Fuck you. This should be a capital F. This should also be a capital F. Now the compiler is going to complain to me because it can't find this. Cool. If instruction demonic dot equals add or instruction instruction. I spelled just instruction dot equals add binary string comparison dot ignore case or equals string comparison dot basically I want to ignore the case. I want to ignore the casing. You know, if they do something else, that's fine. I'm gonna ignore the casing right now. String string empty. And then I actually had an idea for my friend Eric. He was like, you know what you should do? You should just make a video of yourself typing. Like those, because I've actually seen videos of people where they just type, they go on a coding binge or something, and it's a video basically just of the keyboard and them typing on the mechanical keyboard just to hear the clicks. Like, that's a cool idea. I don't know how to set it up, but it's a cool idea. So, process add. Alright, can I sub the array? Just do fucking instruction parts. There we go. Binary instruction. Process add. Cool. Wonderful. Yeah. Not all code paths return a value. Shut up, compiler. I know what I'm doing. Process add. So now we have arguments. So the first thing is we need to get source mode and then op mode. So string instruction mnemonic arguments 0 string go back down here. I see if it's EA or DN or DN or EA. So it's source and then destination is what I'm looking at. Source is equal to arguments 0, 1. String. No, this would not be the source. It would be the mode. String source equals arguments 2. String destination equals arguments 3. Oopsies. 3. And I think that's it. Yeah. Add 1, 2, 3, 4. That is all we need. So, get op mode. So we have if source 0 equals D. So if the source is a data register, else it's not a data register. If the source is a data register, then get the op mode field, so byte word or long. If mode dot equals B, or mode dot equals byte word or long. Okay, so basically if we're in a byte, do one thing. Fuck you, I didn't press Control F, I pressed Control V. Byte word. It's a long word. So then all of this is going to be copied. Oh boy. Oh boy, oh boy, oh boy. All right, this is expanding quite a bit. So here's actually something interesting. I'm probably overhydrated. That's what's going on right now. So here's something really interesting. So software developers, right? I don't really know about coding boot camps, but I went to college. And I was told that one of the most important jobs of software developers is to manage complexity. So that's why you have object-oriented programming. That's why you have different files. That's why we have methods. That's why we have functions. All this other good stuff to manage complexity. Because these things get huge, right? I was helping my friend. They were in a robotics class. And they had to make the robot do one simple thing with the timer as well. And I looked at their code. And I'm like, girl, you need to change your code. You can't use one little variable names. What if you look at it 6 months down the line? You're not going to know what this means. You should add methods. You should make your code more concise. All this stuff. And then they're like, I'm going to run it once and then throw it away. I'm like, that's true. And it really then got me that, yeah, it really kind of showed how software developers are trained differently than non-software developers. People who just will write a C program just to do something and throw it away. It's much more different than the people who are trained to write software day in and day out. It's quite interesting because, you know, with me, I'm copying and pasting a lot of stuff here, which means that this should be put somewhere else. And I know this is just going to get even longer and longer and longer and longer. It's crazy. So, if I wanted to output this, let's go back to here, shall we? If I'm going to write it like this, string output, because right now, I know that's not the best thing to do, not string empty, equals 1101. Now I know this is going to be really long and horrible, but let's just start first. Okay, so now the next part is this, which is the data register. This is the data register. So we have to figure out this first. If source 0, oh my god, I know I am totally duplicating code here, and that's fine. Because I will change it in the future. If the source is D, else. If the source is D, I'm just going to do a switch. Oh, right. We're switching on a string. What? Fuck you. Happy now? Bastard. Case 1. Break. Case 2. Break. Case 3, break, case 4, break, case 5, break, case 6, break, case 7. So I'm thinking what I'm going to actually have to do is pass once to make sure it all makes sense, and then do a second pass to be like, right, now that makes sense, now let's write everything. So if case 0, then output plus equals 0, 0, 0. All right, 0, 0, 0. 1, 0, 0. 1, 0, 1. Da, 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 da. Wait, hold on. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 0, 1, 2. Oh, yes, I can do binary. Oh my god. Ha! There we go. All right. So I had to use my fingers for a minute. And then we're basically going to do the same thing. If source is D, switch on the source. If you're not D, switch on the destination. There we go. So now we have output of that. So now we did this and this. Now it's that. And that is what? Register, this is the op mode. Op mode is this. So the op mode is byte, word, or long. 0, 1, 2, 3, 4, 5. So basically, if the source is D, do that. If the source is not D, do that. Then we have a byte. So if it's a byte, we do 1, 0, 0. Output plus equals 1, 0, 0. If it's a word, output that. Right? Yes. And then 0, 1, 2. This is 0. That's my dog. She's cute and adorable. I don't know if you guys know that. Output that. So we did that, we did that, we did that. Now it's that. Which is the mode. Get mode from addressing. Oh my god. This is just blowing up. Oh, Jesus Christ, man. This is just blowing the fuck up. Okay. Yeah, I think I'm either I'm overhydrated or I don't know. All right, so do re mi fa sol la ti do. We need to put this table in here. It's my dog. Again, you can probably hear her. If the location specified as a source operand, all addressing modes can be used as listed in the following tables. So I can do a dictionary on the addressing mode. But then the question becomes, well, let's say if we do this. Well, the difference is, if the location specified is the destination, only memory alterable. So memory alterable addressing modes. This is memory altering addressing modes. All addressing modes, I guess. I don't know. Hi, puppy. Hi. How are you? It's not time to go out yet. It's only 8:34. You don't go out for another 2 hours, puppy. Come here. Come here. Hello. Hello. How you doing? How you doing? You a good girl? Hmm? Are you a deaf puppy who can't hear me anymore? Yes, you are. Oh, you're so adorable, Lucy. I love you. I love you. I gotta do this though, okay? Come here. Look at me. You're a good girl, okay? Love you. Go play with the cat who you always ignore. Maybe, huh? Maybe he wants to play. Do you ever think you can maybe play with the cat? Old dog. Gosh, the old lady. God. She's gonna be 60 in September. Pen. Okay. There's a lot here. So the effective address is the mode and register. Only alterable addressing modes. I see. So we need a table for addressing modes. I think is what we need here. So alterable addressing modes. So we have alterable data. We have all so far, I guess. Memory alterable data addressing. Memory alterable. Okay. Interesting. So this is getting really long and this is getting giant quick. Like, just figuring all this out is insane. Instructions. Add binary. Because this is just getting fucking giant. Add binary. Cool. Make this public class. Instructions, add binary. Cool. So this is the emulator. Let's get rid of you. Let's go to the test file, right? Okay, so now we have common. Is that a constants file? Constants. This has to be in a class? Happy now? Bastard. What now? Why? Because consorting makes it static. Public const string byte. You're back. So, sorry, yeah, I am in. I am in the. I am in. I'm overhydrated. I'm overhydrated. I can tell I've had too much water, and how I can tell is I get really tired when I've had too much water. That's usually what happens. All right, so we have this. We have the add binary. We have the program. I guess this just be a static class, huh? I don't know. Try to make a static class. No, that's not making a static class. I mean, probably if we make it a non-static class, it'll take longer to compile. That's fine right now. I'm not going to complain. So process add, right? So in add, we are going to get all the arguments. We are going to get all the arguments. Do we have to? Can we just make a static? Let's just make a fucking static class. String. There we go. Public static string parse instructions. So for an add binary, (1101) return output. There we go. So we're going to return the output, which is really cool. And now we need to do all this as what we did before. So we need to know a lot of things. We have the effective address, we have the mode, we have the op mode, and we have the register, which is the data register needs to go into. So basically we need it's 0, 1, 2, 3, 4, 5, 6, 7. It's 3 bits, huh? It's transform basically a string to a string. Of course, we could also do this actually. Instead of string manipulation, add binary could actually just, instead of having an output, it could just have, it actually could output a string, but we could actually just make an array of booleans instead. Dog, what do you want? What do you want? It is not time to go on a walk. Here. Come on. Thank you. Hi. It's not time to go on a walk yet. No, it's not. It's not time to go on a walk. Your walk isn't for like 2 hours, Bubby. Okay? Your walk isn't for like 2 hours. Okay? Okay? I know you just want all the attention, huh? Huh? You just want all the attention you can get. You're an attention whore, huh? You just want all your attention. Don't you? Don't you? Okay? Go play with the kitty. He loves you. Okay, so first thing we need to know is we need the register, we need the mode, we need the op mode, and the register to go to. So we have the effective address, which is a register and a mode. So we could, if we wanted to, we could have a register class, a data register class, that would take a number and return us, that would return us that. So we could do that. So we could have private static string convert string to octet. Actually, case number. Whoa. Switch number. Case 0. Break. 0, 1, 2, 3, 4, 5, 6, 7, 8. And I think there's a thing that would do this, but I don't know if it would output it how I needed to, so I'm going to do this. 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Don't need a default right now. We'll just fine. Return 0. There we go. 0, 1, 2, 3, 4, 5, 6, 7. Sweet. Oh, fine. Happy? What does this do? Go away. Convert string to octet, which will probably be in the data register section. Common, which with that, that's fine. So we can get the data register. So if we have that, this is the data register. This is the op mode. It's the op mode, effective address, EA. So we have mode, register. So op mode, op mode, op mode, op mode is this wonderful thing, which depends on if the source is the effective address or if the source is a data register. So 0, 1, 2, 3, 4, 5. Is there a way to do a case on this? The source is the effective address. What? Tierney's not home. She's in the hospital. Okay. No. Is there a way to do this not using fucking string? Well, I'm going down the route of string parsing anyway, so I can't really complain, can I? So the best way I know is if the source is the data register, it's going to start with D. I know that. So I could do an equals ignore case, and if it's a D, do it one way. So get op mode. Source and destination. Do I really need to know the source and the destination? I just need to know the destination. And I also need to know, so basically I just need to know what the source is. Right. I just need to know what the source is, because if the source is the data. So I just need the source, and I need to know string operand type, which actually should be an enumerator, now that I think about it. Oh well. just get an ad going so we can start to see a pattern in this, shall we? If operand type if source 0 dot equals, this is a car, fuck a duck, equals D or source 0 to D. So if it's the effective address, if I'm going to do the effective address, right? And so I'd have to do add right? If the source is just, fuck it. Okay, yeah, right now, if the source starts with D. Now, if I do the effective addressing, is it possible it could also start with D? Is now my question, right? So, if I have the effective address, right? Source, destination, destination, source, destination. If the source is the effective address, it could be a D. If the location specified is the source operand, all addressing modes can be used. If the location specified is the destination operand, so source plus destination. So basically we have add EAD or add DA. So can EA start with a D? Because the addressing mode can be DN. Which is fine. The location specified is the oh, you can't use DN if it's, okay, I get it. So I cannot use DN if EA. Okay, so my logic here is correct. If the source is DN, right? If the source is equal to D or that, so if the source is direct, so not the effective address, then if operand type equals distance, comparison dot ordinal ignore case or I mean, to make this easier, just copy and paste from here. But really, I think the idea would be, instead of always comparing with ordinal ignore case, I could actually just probably lowercase everything. And that would make everything easier. We can do that later. Okay, if the source is D, if it is not, God, I need a better way to organize this thing. 0, 1, 2. Return output. So now I have the output data thing. If source, if arguments dot 0, 1, 2, 0 is equal to big D, or arguments 2, 0 to little d. Do that. What was I doing? Oh, yeah. Yar. Yeah, this would be the destination. Alright, no, fuck this. Okay. I'm gonna end this here. It's not going well for me right now. I don't know why. I'm kind of annoyed. I haven't been drinking water, so I don't know why I'm so annoyed. Anyway, so there we go. There's a lot more to this than I had anticipated. And this has ballooned a lot. I don't think I should have jumped into code so fast. I just kind of wanted to write something, and I did, and now it's an epic mess. I'm not feeling too good. I don't know why. I'm feeling like I don't want to do this, even though I really like doing this. Maybe because it's late at night. Maybe because I'm tired. Maybe it's the food I had. Maybe I drank too much water. Maybe I didn't drink enough water. I don't know. Maybe I'm tired. Who knows? Anyway, thank you all so very much for watching. Lurkers who are lurking. Viewers who are viewing. 2, 3, 4, 5, 6, 7, 8, 9. Thank you all so much. And I will see you all next time. I'm going to try to do these on Wednesdays now. We'll see how they work. Okay, bye.